Hello. Today we're going to try and prove another fact about functions. One is that if the composition G and F is 1-to-1, then F is 1-to-1. 1-to-1 and surjective are interchangeable terminology. So before we start, let's look at what the definition of injective means. So let's suppose I have a function h, and h goes from x to y. So the definition means that for all x1, x2, and x, and for all of that, if h of x1 is equal to h of x2, then x1 is equal to x2. Fairly straightforward definition. Means that for every x and x1 and x2 and x has exactly one output in y in the codomain or in the image, depending on what terminology you're using. So that's a definition of injective. Now, you can find this kind of problem or this specific problem in discrete math, analysis, abstract algebra, topology. So depending on your text will be depending upon which terminology they use, 1-to-1 or onto, injective or surjective. I'll try to use both during this proof so that you can follow along. Just remember those two things are the same. So we're assuming that G of F is injective, the composition. And let's look real quick of what these mappings do. So I have a set here A, a set here B, and a set here C. So F takes A to B, elements in A, and puts them in B. G takes elements in B and puts them in C. So the composition takes elements in A and puts them in C. That's what the composition does. Now we're assuming that the composition is 1-to-1, and we're going to show that F is 1-to-1. So let's start the proof. We're going to do this directly. So again, we're going to assume that G of F is injective or 1-to-1. And we're going to show that F is 1-to-1. So let's let F of x1 equal F of x2, where x1 and x2 are in the set A. So what we can do here is we can apply G to this equation. So apply the function G to both sides. And then we get G of F of x1 is equal to G of F of x2. Now let's look at just the notation here, and I'll write both. You don't need to include this in your proof necessarily. This should be fairly straightforward to whoever's reading it, but G of F of x1 is the same as saying G of F of x1. And then G of F of x2, you guessed it, will be G of F of x2. So what we have here then is essentially G composed of F of x1 is equal to G of F, and the little circle is the composition notation. G composed of f of x1 and G composed of f of x2 are equal. And since we assumed I'm spelling assumed without proper S's. So since we assumed that G of f is injective, in other words, 1-to-1, if G composed of f of x is equal to G composed of f of x2, this implies that x1 is equal to x2. And since f of x1 equals to f of x2 implies that x1 is x2, thus f is injective 1-to-1 by definition. And that's it. Pretty straightforward, direct proof. Put a little box to say we're done. So in the composition of G and F, G of f of x and the function f, if G composed of f is 1-to-1, that means that f is 1-to-1. And we are done. Thank you for watching. Like and subscribe. And let me know if there's anything you want to see from any of your courses or just out of curiosity. Have a good day.